Hi everyone, as promised this is the heating degree day video. Just a quick recap on what we covered in class. Heating degree day is an indicator of how much heating a building will use over a average temperature during a day, and similarly a cooling degree day is used for how much cooling a building will use over a typical day. So the idea behind these is that we're trying to characterize buildings when their heating and cooling systems turn on, and then as well get rough estimates for how much energy they will use over a day-by-day basis. Originally, as I mentioned, this came from the agricultural world. They were trying to figure out how long crop growths would occur in different climates. The building people picked this up later, typically in like the 1920s, 1940s when it was widely used. Then as computers became much faster, we found out more sophisticated ways. But this is sort of the entry level into creating a building model, estimating how much energy it's going to use, and then we can look at things thinking forward about, what would be the impact of adding insulation or improving mechanical system efficiencies. So this is really the entry level into predicting how a building is going to perform. So I have two equations here on the bottom of the page. One is for a heating degree day calculation over a year, the other is for a cooling degree day calculation over a year. And just remember that there's some reference temperature that you're using. This is part of characterization of the building itself. Typically 18 degrees Celsius is used for a building. So with it you calculate a heating degree day as you take the average temperature of a day. So for example, if yesterday was 16 degrees Celsius, then 18 minus 16 would be 2 heating degree days. And all this equation is saying that you're summing over each day through the whole year. So we're summing over 365 days per year. Exactly the same for cooling degree days, but the signs switch on the equation, so meaning that you only need air conditioning when it's warmer than 18 degrees Celsius, but it's calculated in exactly the same way. So here's the coldest day, or one of the coldest months in Ottawa history. This was February 2015. Going back about 50 years of records, this was the coldest February that we had ever seen. So this is just a quick overview of the temperature profile for one of the warmest days during February. So the temperature started at a little below minus 12, peaked around minus 5, and if you took the average temperature during that day, you would find that it was minus 9.3 Celsius. So the heating degree days for this day was 18 minus 9, or 27 heating degree days. And this is what the whole month looked like. So the warmest day was approximately 27 heating degree days. The coldest day had a little over 40 heating degree days. So if you were to sum over every single day within this month, you would find that February 2015 had 1,000 heating degree days. So to give you a big picture on what typical climate in Ottawa looks like, this is information from a typical meteorological file, or a TMY weather file. The idea behind these files is that we're trying to characterize 30 years of average climate data for a particular location. So in Ottawa, typically what we see over winter for January is about 900 heating degree days, February a little bit under 800, and then kind of down. And similarly for cooling degree days, we would see a little bit over 150 during the peak cooling season of July. Okay, so you can see how unusual February was that year. If we saw a little bit under 800 typically over a 30-year period, and we saw well over 1,000, this was a very cold month during the year. So how we use this is we come up with a characterization equation for a building. This is used using regression techniques from the actual consumption of the building. This is called an inverse model. It's exactly the same from calculating the slope of a line, but instead of the line being given to you, all you know is how much energy is used by the building, and then you know the average ambient temperature of that building. So here are a few different characterizations of a building. For example, if the building had no correlation with as it got warmer it required more energy, you would see a flat characterization equation. for example, as the average temperature increases on this regression model, you would see an increase of energy use. So this is, of course, talking about air conditioning within a building. If you wanted to characterize both hot water and heating of a building, you would use a 3-parameter model. In this case, the first parameter is the average consumption per day. The second parameter is the reference point. I mentioned 18 degrees Celsius is typically used by most standards. And then you have an increase per degree increase of the, per degree decrease of the average temperature outside. So typically these are expressed in this form. B0 or B0 is the average usage per day, so we have to multiply by the number of the days within the year. The B1 is the slope, so the increase per heating degree day of outside, and then B2 again is the balance point at which heating starts to turn on. So I gave the example of 18 degrees Celsius use. You can use a 3-parameter model. Sometimes you might want to use a 4-parameter model, so you're including the heating as well as the cooling characteristics in your regression equation. So this is what it actually looks like. This is metered energy consumption from a real building, and you can see that this is for natural gas. So you can see the average heating degree days plot for the exterior temperature, and you can see the actual energy information of the building. You can see they follow each other approximately well. So these techniques work well for older, larger buildings that aren't well air conditioned or aren't well air sealed, or they're not well insulated. So there's kind of a correlation between, as it gets colder or warmer outside, that the energy demands of these buildings go up. Okay, so let's look at an example here. So for example, if you were given the characteristic equation of a building that looks something like this, we're looking at natural gas consumption of the building. Units are volumes of natural gas, or meter cubed of natural gas. And if you were asked to calculate how much energy a building like this would consume if the average temperature outside was 10 degrees Celsius, here's how you do it. So first we calculate what are the heating degree days for that day. Just minusing, you're given the reference point of 18 degrees Celsius, you find out that there's 8 heating degree days used in that day. So we can estimate for one day that building will use this amount of natural gas. Okay, so we're just taking the heating degree days, plugging them into here. We're taking the number of days of the period we're looking at. You're given that it's for one day, so you're just plugging in 1 here, and then you calculate and figure out that building would use approximately 243 meters cubed of natural gas for that day. We don't have to use a period of day. We can combine, for example, periods of a week. All you have to do is just sum up what the heating degree days are. So for example, this question looks at a period of 1 week for February 2015 in Ottawa. You're given the day numbers as well as the average temperature of the exterior temperatures of the exterior environment that day. You're given the characteristic equation of a building. Again, we're going to look at natural gas consumption just to be consistent. So there's 2 parts to this question. The first one is filling in the heating degree day tables. While if you're given the average temperature outside, you're giving the reference point of 18 degrees Celsius. You just have to use some simple addition to calculate those. And then part 2 is to estimate what the natural gas consumption of this building during the period shown is. So let's start with part 1. So we need to fill in that heating degree day table. Just a quick reference. So if we have day 13 with an average outdoor temperature of negative 22 degrees Celsius, that would have 40 heating degree days for that particular day. So same calculation all the way down. We find here are our heating degree days. And then for step 2 of calculating the total consumption, First, what we need to know is what the heating degree days for that period of 7 days are, and then we need to substitute how many days that we're looking at. So in this case, it's 7 days. So in this case, if we just sum the column of values here for heating degree days, we get approximately 260 heating degree days. We know the number of days is 7, so if we plug this into the characteristic equation that you would always be given, you would find out that there's approximately 2,800 meter cubed natural gas consumption for this period. Okay, so I hope this gives you an overview. Please let me know in the forums how useful you find these videos, and I'm happy to do more of them.